Welcome to The Explainer. You ever wonder how your favorite app can just sift through millions of items and find exactly what you want, like instantly? Well, today we're going to pull back the curtain on that magic. We're talking about how modern databases turn just billions of records into answers in the blink of an eye. So let's dive in.
All right, let's just frame the core problem here. Every major app, every website, they've all got this incredible amount of valuable data. But to get you an answer, they can't just scan one giant list. Nope, they have to piece together information from all over the place. And here's the kicker, they have to do it instantly. So how on earth do they solve this puzzle?
Well, to keep things running smoothly and, not repeat the same information 1,000 times, databases are smart. They store related details in totally separate tables. It's a great way to save space and keep the data clean, but it creates our very first challenge. The info we need is scattered all over the place. So, for example, just imagine we've got employee names in one table over here and the department names in a completely different table over there. Now, if you want to find out which department, say, Maria works in, you have to look her up here, grab her department ID, and then use that ID to find the actual department name in the other table. We need a way to connect these dots.
And the solution to that is a beautiful little command called a join. This is basically the database's superpower for temporarily connecting these separate tables. It uses a common piece of information like that department ID to link everything together for us.
And here's the really key thing to understand. A join doesn't create some new permanent master table. That would totally defeat the purpose of keeping data separate in the first place. Instead, it just creates this temporary, combined view specifically for the question we're asking right this second.
And bam! Here's the result. Just like that, we've got a single, super easy to read list with the employee's name right next to their full department name. Problem number one, solved.
Okay, so we've joined our data, we've got everything in one place. Awesome. But now we have a brand new problem. The results are often just jumbled up in whatever random order the database happened to store them. It's a total mess and pretty hard to find anything. It's exactly like looking at a messy folder on your computer. You wouldn't just scroll through thousands of files randomly, right? Of course not. You'd click sort by name or sort by date to bring some order to the chaos. We need to do the exact same thing here.
And the sorting process itself? It's a really simple three-step deal. First, you get your combined, joined-up data. Second, you just pick a column you want to organize everything by, like maybe the name. And third, you tell the database how to organize it, say alphabetically. Easy.
And we've basically got two main options here. We can sort in ascending order, that's A to Z for text, or smallest to largest for numbers, or you guessed it, we can sort in descending order, which is just the exact opposite.
And just look at that transformation. Our messy, combined list from before is now perfectly organized by employee name. It's clean, it's logical, and it's so much easier for a human to actually read and find what they're looking for.
So we can get organized data. Great. But what happens when our table doesn't have 10 records, but 10 million or 100 million? The whole process of joining and then sorting that much data would be, incredibly slow.
Just think about the sheer scale of a national ID system or a social media platform or a big online store. Searching and sorting that volume of data on the fly could take minutes, not milliseconds. And let's be honest, users will not wait. We need a way to make it practically instant. To solve this massive speed problem, we use this really powerful concept called an index. And the absolute best way to understand it is to think of a book's table of contents. Instead of flipping through the entire book page by page, you just go to the index, and it tells you exactly where your chapter begins.
And that's pretty much what an index is. A separate, highly optimized lookup file. It doesn't change the main data table at all. It just acts as this super efficient guide, telling the database exactly where to look without having to scan every single thing.
Now, we apply indexes strategically, right? You put them on columns you know you're going to search on a lot, like a user ID or a person's name. And when we do that, the database builds this special sorted data structure behind the scenes. The cool part is, we just have to tell it what to index, and it handles all the complex how part for us, turning a long full table scan into just a quick little lookup.
But, like any powerful tool, indexing isn't some magic bullet. It definitely comes with a trade-off. It makes one thing much, much faster, but it can make other things a little bit slower.
The main advantage, obviously, is lightning-fast searches. But here's the cost. Every single time you add, update, or delete data, the database has to update not only the main table, but also that index file. So this makes data entry just a little bit slower. And of course, that index file itself takes up extra storage space.
But look at the payoff. The performance gain you get for searching isn't just a little bit better, it is dramatically, orders of magnitude better. For any database of a serious size, this trade-off is almost always worth it. It's a no-brainer.
So let's just pull all three of these ideas together for a second. We've basically tackled three different problems, each with its own really elegant solution to get us from a complex question to a lightning-fast answer.
We started with that scattered data, and we used a join to bring it all together. That created a messy view, which we then cleaned up with a sort. And finally, to make sure this all happens instantly across millions of records, we made it fast with an index. Join, sort, index. That's the secret sauce.
And that's how databases manage to tame all this complexity to deliver information in a heartbeat. So, now think about the apps you use every single day. Your social media feed, your search engine, your favorite shopping site. Which one do you think would completely break first without this incredible need for speed?